Okay, so I'll try and remember to do this every class, put, like what we're going to do today and then what's coming up next class, just so you have an idea. By the way, I went in my office and worked that thing out and got an answer. It's pretty cool. You should see it. I'll show it to you if you have time after. Okay. All right, so today we're going to start. This is our first official day of lecture, I guess. And we're going to cover linear equations and inequalities. And then next class, you need to have the homework for this section done, and that will be on Thursday. And the homework assignments are on that schedule. So it's 1 through 23 odd, number 29, 31, 35, 57, 59, 61. So that homework, you should complete it to the best of your ability, bring it into class. And what I'm going to do is I'm not sure how I'm going to do it yet. We might pass them around and then you grade each other's. I thought that would be fun. Or I just collect them and I pick 3 random problems from the assignment and grade just those 3. And which problems they will be, that's just random. I'll just pick them, all right? Because I don't have the time to grade the entire homework assignment. It's just not enough time. So, and then the review that I handed out first day last week, go ahead and have that ready to turn in on Thursday also. And then we'll start 1.2. All right? Any questions? What should you do if you run into any homework problems with the homework 1.1? You can message me, send me something through Canvas. I'm going to try, remember the first day I said I'm going to try and work out all the homework problems on video. I'm already behind on that, and the reason why is because last week they were trying to pull me out of this class because we lost our differential equations instructor. He had to go somewhere, so they wanted to go put me on differential equations and then bring someone in here, and then in 7 weeks bring me back. And so basically I was scrambling to try and get ready for a course and lost a lot of time, but then it turned out that it didn't happen. So I'm behind is what I'm trying to get at. So I'm going to try and get caught up with the homework assignments. No promises, but if you run into any trouble, just message me. You have my cell phone number. Okay? Good? All right, so let's get started. We are going to do 1.1, linear equations and inequalities. Now, that's the title of the section, in the book. Also keep in mind, this video will be on YouTube later on today. All right, and it'll be linked through Canvas. You just click on video lectures. And so if you're doing your homework and you want to go back and look at something, most of the time, all your homework problems, I'll do something similar to them. It really only gets kind of messy when you get to word problems. That's when I can't do an example of every type. So, all right, so 1.1, I want to kind of change the title, even though it says linear equations and graphs. I'm going to put linear equations in one variable and then I'm going to put linear inequalities again in one variable. All right, so that's what we're going to look at today, linear equations and linear inequalities. But both of these topics, we're only going to have one variable in the actual expressions. We're not going to have multiple variables. That'll come later. So let's start out with the first example. And this is something from our review. So this is not brand new material. So your first example is to solve, and I'm going to try and stay consistent with what the book's doing. So I'm going to be doing problems that are very similar to the examples out of the book, but I'm not going to work the examples from the book. They're just kind of like matched problems. So here we go. We're going to try and solve 3x minus 2 parentheses 2x minus 5 and then equals 2 parentheses x plus 3 minus 8. So we are trying to solve this. There it is. It's a linear equation. Now it's an equation because it has an equal sign, right? And it's linear because the variable that we see, x, is raised to the first power, right? And there's one variable, obviously, because there's just an x, right? All right, so what's the goal, the method? What do we do here? What's our ultimate goal? Is to try and do what?
Orders of operation.
Orders of operation, okay. To do what? To get x by itself, right? So we want to isolate x. Okay, so want to isolate x, get it by itself. And the things that we're allowed to do are add or subtract things from both sides and multiply or divide both things from on both sides, right? It's an equation. It's like a balance. We can do something to one side as long as we do it to the other side. But before we do that, we want to try and remove parentheses, right? So this is where like the order of operations comes into play. We want to try and get these parentheses to go away, and on this side, the right side, the parentheses go away. So what we'll have to do is distribute, right? We'll have to distribute the -2 through the parentheses. We'll have to distribute the 2 through the parentheses. So let me go ahead and do that. I'll just draw. Okay, and let's have some fun. Mark, Morgan, where's Mark? No Mark? No, all right. Not here. And how about Benjamin? Benjamin? What's the probability that I call the two people who aren't here first? Benjamin's not here, all right. How about, is it Kobe? Did I say that right? Kobe? All right, so Kobe, I'm calling on you, okay? It's fun, right? It's fun, it keeps you on your toes. If you get it wrong, no one cares. No one's gonna walk out of here and be like, I got Kobe, man. Right? Who cares? So, Kobe, I just want to know if you can give us what the next line should be.
I got 3x minus 4x
Plus 10 equals?
2x plus 6 minus 8.
There we go. Okay, anybody disagree? Good. Anyone have a question as to what happened? We're good? All right, awesome. Good job, Kobe. I'm taking attendance this way today. All right, any volunteers for the next step? Any volunteers? Okay, I'll get you the next one. What's your name?
Renee.
Renee. All right, Renee. So can you tell me what you're going to do and then tell me what you get?
Find like terms on each side of the equal sign.
Okay, good. So you're going to collect like terms on the left and right side. Okay, so what do you get on the left?
Negative x plus 10
Good.
equals negative 6x plus 6.
This one didn't have an X on it.
I'm sorry.
Yeah.
2x
2x, there you go.
minus 2.
Minus 2. Okay, minus 2. You said minus 2, I wrote minus 8. Okay. Anyone disagree? We're all good? Sure? Any questions? You okay? Right here? Yeah. If you have 3 x's and you take away 4, you're going to be minus 1, right? All right. Volunteer for the next step. What's your name?
Christian Prado.
Say again?
Christian Prado.
Gotcha.
And you're going to add to the other side.
So you want to add 2 here and add 2 here?
Yes.
Okay, so you're making a conscious decision right now to try and get all your numbers on one side and your variable on the other side. Is that what you're doing? Okay, so you want to add 2. I'm going to do it vertically here. Add 2 here, add 2 here. Are you going to just do that or you want to do anything else? Just that for now?
Just that.
Just that for now, okay. Sometimes people will do the x's at the same time. Okay, so this is fine. We'll just add straight down. And Christian, what do you get? What's your next line then?
It is negative x plus
Good.
is equal to 2x.
good, okay? Any questions there? Everyone's good? All right. Okay, let's see. What about Zachary? Zachary? Oh, well, wow, okay. Zachary, what do you got? Feel comfortable with this?
Yeah.
Okay, what do you want to do?
Move 2x over, or move the, before I forget, move the 12 over first.
Okay, so
Subtract 12.
are you want to subtract 12x, put it over here, and then, 12, and then bring the 2x here? Is that just because, like, the habit of your whole life has always been to put x on the left?
Yeah, it's always been x.
It's always been x on the left. So that's okay, and you'll still get the same answer, but let's understand also that it doesn't matter what side x is on. And Christian already went through the effort of putting the numbers on the left side, right? So why don't we instead try and force the x to the other side? So how would you, Zachary, get this negative x out of here? Just add it, right? So you add here and add here. Let's do that. Do y'all see that's probably a little more efficient than trying to move everything back around? Okay, so this is gone. We get 12 here and then 3x. Zachary, I accidentally did that for you. So why don't you tell us what you would do now? Division? What are we dividing by? What are you trying to get? What are you trying to get by itself? The x, right? So you want to get rid of this, right? So divide both sides by 3. Yes? Okay. So divide by 3, you get 4, right? X is 4. That should be our solution. Okay, so we went very slow through that because, it was a long weekend. Everyone hopefully had a good weekend, so get warmed up here. All right, that's a linear equation. We distribute it through, collect like terms, move our numbers and variables to opposite sides, and then divide if we need to and get an answer. And you could, of course, check this answer, right? You could plug 4 in, 4 here, 4 here, 4 here, and if it turns out to be left side equals right side, then you have the correct answer. All right, good. Now let's do something a little different. Another example. I'm going to just put EX, for example. And then I didn't label the first one 1. Let's just call this example 2. Go ahead and go back on the last one and put example 1. All right, this one is going to be different. And I think I will use the one that they use in the book because it's a business kind of finance problem. So if you have this formula, A equals P plus P RT. Now I put dots here so that you understand there's multiplication, but I'm going to get rid of them because if we don't put them, it's implied that they're there. All right, so look at this equation here. Is this a linear equation?
Yes.
Yeah, because none of your variables appear to the second power, third power, but it is a linear equation in one variable. It is not, is it? But I said this was a section on linear equations in one variable, right? This is not one variable. You actually have 3 of them. Now, the reason why it's still valid for us to use this right now is because in a word problem, what will happen is they will give you 2 of these variables. In the how many do we have? Sorry, 1, 2, 3. We have 4 variables, don't we? In a word problem, they would give you 3 of the 4 variables and leave you with 1. Okay, but this is a general formula for computing how much money you would have in an account after a certain amount of time if there was a given interest rate. So that's what these letters stand for. A is amount. P is what we call the principal, which is how much money you would put in initially. So you go to the bank, you say, hey, I'm going to give you $1,000. You leave it in there for a certain amount of time. They pay you a certain interest rate, and then this calculates how much would be there after that amount of time. So here's the first thing I want us to do. Solve for A. Okay, this will be part 1 of this example. Okay, so let's see who's going to get lucky here. How about, this is an interesting name. Is it Tressa?
Tresca?
Tresca.
Yeah.
I thought that C was silent. Tresca. Okay, Tresca, you got the easy one. I hate saying easy, but we're being asked to solve for A here. So do you need to do anything? Here's the given equation. It wants you to solve for A.
Do you need to switch them around? So
What does it mean, everyone? What does it mean when you say solve for A? Get A by itself, right? And everything else on the other side of the equation.
put the P plus PRT on one side.
Pardon me?
Or put the P plus PRT on the left side.
You want to put this over here?
I don't know, it just makes it easier to.
Ask yourself this question, Tresca. Do you have an equation where A is by itself? Okay, so then you don't need to do anything to it. So it's a trick question because there's nothing to do, right? This is already done. There it is, right? There it is. A is solved for. So that means that if somebody gave you P, R, and T, right? If somebody told you what P, R, and T were, you could tell me what A is just right off the bat, right? Plugging them in. But that's not always the case. So how about this? Part 2, let's solve for, let's go for T. Let's solve for T. Any volunteers for T? What I mean is I want you to rewrite this equation doing whatever you want, but get T equals and then a bunch of junk. Go ahead.
Could you just divide T out on both sides?
Divide here T and divide here T. So you'll have A over T here, right? And you'll have P. You would have to divide this by T, and this by T. I don't think you're going to get T by itself. Think about like in this problem, right? When we were trying to solve for X, we were trying to get everything off the side that X was on, right? Same principle here. What could you do first to what was your name?
Aaron.
Aaron?
Do A minus P divided by PR.
Okay, good. So you did them both. You already did it all. So you're saying first thing, we're trying to get T by itself, but T is stuck to this, right? So you first move the P over. And to do that, subtract P on both sides. So that's what we're going to do first. We're going to take A equals P plus PRT. And you subtract P here, subtract P here. Is that legal? Can we do that? Can we subtract P from both sides? Sure. All right, so P goes away. And on the left side, what's A minus P? I don't know. A minus P. I don't know what they are, right? So I just have to write A minus P. Then equals PRT. And then Aaron, you already said from there, to get the T isolated, you saw that you had multiplication here. So you divided both sides by PR, right? So that would be the correct next step. Divide by P times R. Divide the whole thing by P times R. And what you would get is A minus P, that whole thing divided by P times R, equals, and on the left side, the P's and the R's cancel, and you just get the T by itself. You all follow that? Okay, so that's it. Now, think of it this way. If somebody were to tell you the amount, how much you put in, right? The amount that, how do I say this? If somebody told you the amount of money you wanted to have, right? If you put this much money in the account at a certain interest rate, this would calculate how much time it would take for that to happen. Understand? Here, the first one, right? Somebody would need to tell you how much money you're putting in, what the interest rate is, and how much time you're leaving it there, and this would spit out how much you would have after that amount of time. So in certain applications, sometimes you want to know the amount, sometimes you want to know how much time it's going to take, right? It just depends on the application. All right, third one. How about we solve for P? Now let me give you an example of this. If we're solving for P, then what are the things that someone would have to give us in order for us to want to use this equation? The rate, the time, and the amount. So this is actually a pretty natural question. Because let's say that I want to have I want to have $10,000 in the bank. I want to leave some money in the bank for 5 years. And I know my bank will give me a certain interest rate. Then this answers how much I need to put in right now to have that $10,000 in 5 years. So this again is applicable to the real world if you're trying to, forecast down the road. All right, any volunteers for solving for P? We're going to start with this equation again and try and get P by itself. This one's tough. This is the hardest of the three I've given.
Would you divide the rate and time out first?
Okay, so let me write this down. It's not going to work, but I want someone to try something. I mean, there's nothing worse than not trying, right? So you're saying divide by the rate and the time? I agree. That would get, if you divided here by rate time, that would get rid of, you get P by itself, wouldn't you? But you've got to divide this by rate time. You've got to divide that by rate times time. And what's going to happen is even though P's by itself here, this P is being divided by RT. It's like, what are you going to do with that? It's going to become messy. So good try. Let's try something else. Like I said, this one's tough. Sometimes you just have to see this one the first time.
Do you subtract the PRT?
Okay, so you could subtract this. Let's try that. If we subtracted on both sides, we would get A minus PRT, right, equals P, right? And then you're going to tell me, yeah, I solved for P, right? I agree, you have solved for P. What's the problem with this?
You don't know what it is.
Okay, so this means in order for me to know what P is, what am I going to need to know? A, R, T, and P. I can't know P if I need P to find P, right? So this isn't going to work.
Factor it out.
Pardon?
Can you factor it out?
Factor it out. There we go. That's the one. Okay, on this side to start, right? Factor P out first. These both have P in it, right? So let's take A. Let's go P. Let's pull out a P. When we pull out that P, what are we left with?
Would P, the other P be like a 1?
Okay, so we need a 1 here plus RT. Just be careful that you don't put just RT in here. It's 1 plus RT, because when you distribute, you need to get back 2 terms. So there has to be 2 terms in here. Do y'all see how that works? Okay, good. What was your name, by the way?
Benjamin?
Okay, let's see here. Just so I can count you present here. There. Okay, gotcha. All right. How about Miguel? Did we get Miguel yet? Miguel, did you volunteer yet? No? No. Okay. Miguel, do you have any idea what to do with this if you're trying to get P by itself?
Just divide it.
There you go. That's it. This is multiplication, right? You're going to divide that big chunk of stuff on this side and this side. All right, so we're going to divide this entire side by 1 plus RT. And we have to do the same thing over here, 1 plus RT. And so what you get, what's the left side, Miguel?
A over 1 plus RT.
Okay. And then equals P. That's it. We have solved for P. You can do this with pretty much any equation. That's actually off camera. Now that I'm looking, that's off camera. But you get the idea, right? There's another, I'm not going to go through this one, but I'm going to put up another formula just so you can see it. Anyone ever seen that formula before? That's a chemistry formula. Pressure times volume equals number of moles times Avogadro's number times temperature. Anyway, it's an equation. Now, if someone gives you that, they could ask you solve for P, solve for V, solve for N, solve for R, solve for T, right? Same thing. We just move things around. All right, moving along here. Let's move into linear inequalities. That's it for linear equations. 2 examples. All right, now before we can talk about linear inequalities, we have to understand what inequalities are, all right? So the key word here, the key difference in what we're doing now is that little in the front, inequalities as opposed to equations, right? So in our mathematical system, there are four inequality symbols, and we all need to understand what they are. We have this, 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 and this. And I don't like to name them because, like if you call this the greater symbol, less than symbol, I don't like to name them because it all depends on the order in which you put things. So let me just write some things down and see if it makes sense to you, all right? So let me try and use some symbols. This is going to be example 3. Oh, whatever. Example 3. All right. Tell me the relationship between 5 and 11. Which one of those is bigger? 11, right? 11 is bigger. So which symbol would we use? Let's call this the first one, the second one, and third one, and fourth one. So which symbol would we use there between those two?
2.
We'd use symbol 2, right? That one right there. How would you say this? How could you say this to someone? Like in words, what would you say? 5 is less than 11, right? What's another way you could say that? 11 is greater than 5, right? That's why I don't like to name these symbols like greater than, less than symbols, because it all depends on how you want to say it. If you read this from left to right, it's 5 is less than 11. If you read it from right to left, it's 11 is greater than 5, right? Okay. How about this one? Which symbol am I going to use?
1.
First one? -5? Okay. So we all agree with that? This is the one that confuses people sometimes because they're like, well, -11 it's a bigger negative number, right? But it all depends on where things lie on the number line. So next to these 2 examples, I'm going to draw a quick number line. If you draw a number line, if this is 0 here, right? 5 is here and 11 is here, right? So 11 is to the right of 5, which means 11 is greater than 5. 5 is to the left of 11, so that means 5 is less than 11. So it all depends on the order they appear in on the number line. If I draw this number line, here's 0, -5 is here, -11 is here. So -5 is to the right. That means it's bigger. So -5 is greater than -11. All right? How about this one? Which symbol do I use? 3 or 4? 3 or 4 would work here. Let's see why 3 would work. How would you say this in words to me?
4 is less than or equal to 4.
You could say 4 is less than or equal to 4, or you could say 4 is greater than or equal to 4. The key is that bar underneath means that if you have equality, it's okay to use the symbol. Okay? All right, and I'm getting the feeling that y'all understand this. All right, so let's try something else. Example 4. I want you to graph x is greater than 3. So this means I want you to graph, well, can anyone give me a value of x right now that's bigger than 3? 4, what else? 5, 6, how about 7.256? How about 7.257? But 7.256,752. Okay, so why don't we just go around the room, we just keep giving examples. And we'll just keep doing that until we die, right? We would never have enough time in our lives to give every possible answer to this, right? So what we do is we try and visualize what it is. And on a number line, if this is 0, 3 is out here, right? 1, 2, there's 3. The way to represent all the answers that we're trying to say, right? 4, 5, 6, all those, is we shade in everything bigger than 3. So everything to the right of 3, like this, forever. Put a little arrow like that. And then what about 3 itself? Is 3 an answer to this? No, 3 is not bigger than 3, right? So how do I tell you everything but not 3? I don't want 3. Yeah, there's 2 standard ways to do it. The book uses a parenthesis, like this. Okay? But you can also put an open circle. So I'll show you the other notation below this. Open circle, like that. I'm okay with both of these. The book uses this. All right? That would mean everything bigger than 3. So is 2.99999 there? No. Is 3.0000001 there? Yes. Is 3.0000000000001 there? Yes. As long as it's not 3, as long as it's a little bit bigger than 3, we're good, right? Okay. Let's keep going with this example. Still example 4. How about this? How about x smaller than -5? Let's go less than or equal to. Any number that you can come up with that is less than -5. That means to the left of -5. So -6 would work, -7. So when I graph this, here's 0, here's -5. I'm going to do what? I'm going to shade the number line, part of it, right? To the left, right? To the left of -5. And then what about at -5? Am I going to do the parenthesis, open circle, filled in circle, right? Or the book uses a bracket. So the book uses this notation, a bracket. And you may also use a solid dot. Just make sure it's solid. All right? We still good? Let's try this. Still example 4. I want you to graph this. This is called a compound inequality. -3 less than x less than 4 equal to. There, I'll just make it like that. Can someone first give me an example of a number that would satisfy this? 2. Is 2 bigger than -3? Yes. Is it smaller than or equal to 4? Yes. Someone else give me an example. 1. Someone give me an example of something that's not in there. -4. 5, I think I heard 5, right? So there's a bunch that aren't, there's a bunch that are. So let's try and graph this. So here's what we're going to do. We're going to write these down in order on the number line. Notice I'm not like marking out 1, 2, 3, 4. I'm just getting like, make sure I get what's on the left and what's on the right correct. I want everything between these two, right? Everything in between. Now what about at -3? Do I want -3? No. So I should put a parenthesis there. And then do I want 4? Yes, so I put a bracket here. We good? This right here, this compound inequality gives us what's called an interval. This is an interval. The other ones that we were looking at were also intervals. Everything we've drawn so far, those are called intervals. How about this one? I'm going to see if I can get you on this one. Can anybody give me an example of an x that would make this true? I didn't hear that. Can anyone give me an x that would make this true? -8. -8 is less than -7. I agree with that. But is -8 greater than 2? No. This is impossible, right? This is not possible. So, but I still want to know what the answer is. Undefined. Any others? No solution. Right? Okay. So technically, the correct way to say the answer to this is you could say no solution, all right? Or you could use a symbol. And the symbol is a 0 with a line through it. Now, for those of you who have military backgrounds, they use this for 0 in the military, but in mathematics, it is the empty set. That's what that notation means. It's the set of nothing. Just imagine it as an empty basket. It's a basket that has nothing in it. This right here, your basket has everything in here, right? All the numbers in here are sitting in your basket. Those are your answers. This is saying, hey, look, I've got a basket and the answer's in there. There's nothing there. Okay? It's empty. All right, now when it comes to intervals, there are several different types of intervals. So let's kind of review them just so that we are aware. Because this is going to come up quite a bit as we proceed through the class. You're going to be using interval notation a lot. So intervals. Okay, you could have a situation like this, where let's say you have some number, A, and it's shaded to the right forever, and it's not including A. Now, the notation we would use for this, okay, this is the interval. The notation, this is the graph of it. Here's the notation of this interval. You would write like this: A, comma, infinity, parenthesis. So if you write this down, what you mean is everything from A out to infinity. That means positive infinity, out that way forever. The parenthesis on the A means don't include A. The parenthesis on infinity is there because you always have to put parenthesis on infinity. Always. And it's just because infinity is not a number. It's an idea. So you can never actually get to infinity. All right, what would be the difference if I took this same interval, but this time I included A? How would my notation change?
You would put a bracket.
I put a bracket here on the A. And then on the infinity?
The parentheses.
Yeah, always the parenthesis. And then we could have it the other direction. What if we had this? A here, shade this way, forever, parenthesis. And then I'll do the one below it, A here, bracket, shade this way forever. So how would that change? You always read these left to right. So as I move from left to right, I need to start way out there at negative infinity, and then to A, and then what here?
Which one are you doing?
This one right here,
Oh, the parentheses.
parenthesis. Yeah, these go like this.
Okay.
And then the next one, negative infinity to A with a bracket like that. Okay, those are your four. These are called like infinite intervals because they go forever in one direction, either to the right or to the left. Now what about this? So I'm going to continue over here. What if you have this? Everything. Everything, both directions forever. Negative infinity to infinity. What if you have this? A to B, not including A, not including B. Everything in between. Parenthesis, A, comma, B, parenthesis. And then you could have A, B, include A, don't include B. So what would happen? Bracket, A, B. And then there's two others, right? You could include the B's now. So you could have like A, B, and you could have A, B like that. I'm not drawing those, but those are two more you could have. Okay, one more that I want to show you. What about this? How do we write this? I'm more interested in the notation that we use for this situation. What if we have A, B, everything between A and B, not including A, including B, and everything from C to D, let's say including C, not including D. How would we write that? What would be the notation for that?
So you do like parentheses A
Parentheses A,
with the bracket, the B,
bracket on the B,
and then you do the bracket C,
bracket C,
and then parentheses.
parenthesis D on the D. That is correct. There's one more thing we put in there just as like standard notation. Not a comma. That's why I wanted to do this. So if, naturally you would think just put a comma. It's this and this, right? Have y'all ever seen this symbol?
Yeah.
It's a big U. That means union. That means, you remember how I was talking about these answers are like a basket? This says, hey, look, you've got this basket, and you want to union it. You want to put it together with this basket of numbers. You have two baskets of numbers. They're union together. Those are your solutions. Make sense? So this is the union symbol. All right, this will all come up later. All right, so let's now solve an inequality. That was all just leading up. Let's solve an inequality. What example am I on here? 5? Okay. Example 5. Solve three parentheses x minus 1 less than or equal to 5 parentheses x plus 2 and then minus 5. All right. Okay. Mercedes or Leah? Mercedes Leigh. Okay. So you ready?
Yeah.
All right. So I want first for you to let me see. Tell me what you're looking at. Can you tell me what that's called? Like, what is this thing called? A what? I think you're doing.
Inequality in one variable.
Okay, good. So only thing you're missing there, linear. That's it. So this is a linear inequality in one variable. So we have done linear equations in one variable. Linear inequalities, how do we solve those? We have not done one of these. Well, it turns out the methods are exactly the same as linear equations. You want to isolate the x. So why don't you go ahead and start us out? What would you do first here?
Multiply the 3 times.
Okay. So you're going to distribute that through?
And then on the other side,
5 through. Okay, what would you get if you did that?
3x minus 1 less than.
Careful, hold on. 3x.
Minus
3, okay.
less than or equal
Okay.
to 5x plus 10 minus 5.
Good. Okay, great. All right, Alejandro, where's Alejandro?
Right.
You're up. I can give you time to write that down if you'd like.
Oh, it's cool.
All right, what do you got, Alejandro? What are you going to do?
Would we combine the same numbers like 10 and 5?
Yeah, this is the only thing you can really do is that, right? Okay, so let's do that. And since you had no problem with that, you can go ahead and take us to the next step too. So what would you do now? This is kind of your call at this point.
And we can either like move the x or the 3x over, or we can move the minus 3 over.
Yeah, it's up to you. What do you want to do?
Just add 3 to
You want to add 3 to both sides? Okay. All right, I'm going to let you off the hook now. Adding 3 here, adding 3 here. We've got 3x less than or equal to 5x plus 2, right? Okay. It's going to get a little messy here. Is it Kane?
It's a plus 8.
Oh yeah, why'd I put minus 3?
I did the same thing.
You put, okay. We call those brain farts. Okay, so plus 3 on both sides, obviously. Adds up to the 8. All right, is it Cain? C-A-I-N-E. No, not here. How about Jordan? Jordan? Okay. Jordan, what do you want to do?
5x over the lower side, so you're going to take it away.
Okay, so you're choosing to put your x's on the left side. No problem. I'm okay with that. I actually like that because you already have numbers over here, so just leave them over there. Subtract 5x, and then what would you get there, Jordan, if you did this?
2x.
Yep, negative 2x. And then we would say, how do you say that middle piece? How would you say this? Less than or equal to, and then you still have 8 there, right, Jordan?
Yes.
Okay, I'm going to take a volunteer for the next step, because the next step is tricky. Can be. What do you got?
So you're going to divide out the negative 2 to both sides.
Yep.
Then you're going to switch the less than to the other side.
Yeah, what the hell's all that about? Hold on, let's do it. Okay, we're going to take negative 2x, and we're going to divide it, right, by negative 2. We're going to divide it by negative 2, because that's what you need to do in order to get rid of the negative, right? When you do that over here, no problem. But with inequalities, and only with inequalities, when you divide by a negative or multiply by a negative, this inequality symbol flips over. So it's going to flip and become greater than or equal to. And it's because we divided by a negative. Have y'all ever wondered why you have to do that? Nah, you just remember do it and that's it. Who cares, right? It has to do with the fact that a negative times a negative is positive, right? Or a negative. Anytime you take 2 negatives and multiply, you get a positive, right? And so when you do this, it changes, things change, and so you have to flip the inequality to account for that change. I'm not going to get too much in detail, but it has to do with that. So what is left? What do we have left when this happens? X greater than or equal to negative 4. And now, even though that is correct, we're going to graph this, and then we're going to write it down in interval notation. Okay, so the graph of this, I put negative 4, and then it's everything to the left or to the right? To the right. And do we want negative 4 or not?
Yes.
Yes, so what do we do?
Bracket.
Bracket. And then that's the graph. That's us drawing it. Now the interval notation. So the notation for this is bracket negative 4, comma, infinity, close it off, parenthesis. All right. Is everyone okay with that? Questions? We're getting ready to do a couple of word problems here, but we're going to do one more example. Example 6. Solve. Negative 8 less than or equal to 3x minus 5 less than 7. I just realized I forgot my coffee. That's what's wrong. I forgot my coffee today. It's in my office. All right. This is a compound inequality, right? But we'll do that next time. Y'all have a good day. We'll see y'all next class. I'm kidding. I had to do that. I had to do that. Welcome. You're here at least, right? It's fine. You don't have to explain. You're here. I just like to do that when people walk in late. Be like, all right, that's it. And you're like, shit. Okay. Is your name Kane? No? Mark? Okay, I haven't called him. Compound inequality. 2 inequality symbols, right? Anyone have any idea what to do? Add 5, right? So look, think of it this way. If that was the problem, would everyone be comfortable adding 5 to both sides? Okay. And if this was the problem, would you still be comfortable adding 5 to both sides? So the way compound inequalities work is that same thing, except you're going to do it to all 3 sections. Whatever you do here, you must do here and here. So we're trying to get this x by itself. We add the 5 first. So add 5 here, add 5 here, add 5 here. All right, and is it Sierra or Kiara? Kiara. Where are you? Kiara. Okay, Kiara. Kiara, do you know what the next line will read?
-3
Okay,
is less than or equal to 3x.
good.
Less than 12.
Yes. Okay, good. Good. And then Alexis. Where's Alexis? All right. Any ideas, Alexis? Trying to get this x by itself? What you do? Divide by 3. And you got to do it to all of them, right? Now, do you have to flip over the inequality? Take some time first. Why did we flip the inequality here? Why did we do it here? Because we divided by a what? Negative. Are you dividing by a negative when you divide by 3? No. So you do not have to flip it, all right? So you just divide by 3, divide by 3, divide by 3, and we should be in business here. Alexis, I'll let you tell us what it is. Negative divided by a positive should be negative still, right? Just -1. Less than or equal to, 3's are gone. So you have just your x, right? And then 12 divided by 3, we've got 4. And we've got our x, right? We've got it. If we draw this on a number line, here's -1, here's 4. Everything in between. Bracket on the left, parenthesis on the right. And Dylan, where's Dylan? Dylan, can you give me the notation, the interval notation for that answer? Okay. 4, parenthesis. Okay, good. So that's it. Now let's not lose sight of what we're doing here. We are trying to find the solution to this inequality, right? This original inequality, we're trying to figure out what x's work. And our answer is that if you pick any x here, give me any number between -1 and 4, it will work in there. But you have to be careful. You can have -1, it will work, but if you try 4, it's not going to work, right? But everything in there works. So there's an infinite number of answers in there, isn't there? An infinite number. All right, let's do a word problem. Example 7. All right, Mary pays 8.5% sales tax and a $190 activation fee. For her new iPhone 10. She's getting the 10 because look at the activation fee, $190. That's a special edition, all right? The new iPhone 10. Her total cost was $1,345. And let's put some cents on here for real world, right? 90 cents. The question is this: what is the price of the iPhone 10? I mean, that's $1,345.90 is how much she paid at the end, tax and everything included. But can you work backwards from this and figure out what the base sale price of the phone is? Yeah. Okay. All right. So let's try and do this. There's so many ways to get to this answer. But let's try and do it in a systematic approach. All right? Let's try and set up an equation. And I'll help you out by starting out. The total cost, right? The total cost should be equal to what? It's this number right here, right? But tell me what that is made up of. It's the price of the phone itself, plus the activation fee, all of that times the sales tax. Agreed? So watch the way I'm going to write this. This is the price plus activation, right? All of that times sales, right? Or we should, no, you know what? Let's do it this way. I like this way a little better. Price plus activation plus tax. All right, let's do it. That I think makes a little more sense. You're going to have the price of the phone plus the activation fee, then you throw the tax onto the whole thing, right? Agreed? All right. Now, let's stop using words and let's use letters. Why don't we call the total cost over here T? Is that okay with you? The price of the iPhone, let's call that P. The activation, we could call it A, but we know what it is, don't we? We know it's 190. That's not going to change, is it? Plus the tax. We're already using T over there. So X, okay. We okay so far? Can I replace anything here? Can I replace anything? Is there anything else I know?
Yeah.
The capital T, right? This is actually 1345.90, right? So let me go a little bit further. I could have done that in the beginning, but I was trying to get you to see I'm setting up an equation. 1345.90 equals P plus 190 plus X. Y'all still good with that? What is it that we're trying to find in this equation? We're trying to find P, right? We want capital P.